Alright, so in the previous lecture, we looked at a read input registers command and simulated it using modscan32 and modsim32. And it was the same command that we saw, actually data streams, we saw what the data streams are supposed to look like in the previous lecture. And so in this lecture, we're going to look at the data traffic for that. So we're going to compare it with what we anticipated. Okay, so I have modsim32 set up as before. And I just restarted modscan32. A reason I restarted it is for the transaction identifier, and I'll tell you why. So let's click on this button here, show traffic, connect, and there we go. And disconnect. All right, just have a look at this traffic here. This here is our query stream, and in black here is our response stream. All right, so here we go. 1 and this 0, these 2 bytes here, 1, that's our transaction identifier. 00 is our protocol identifier. 06 is the length of bytes remaining or to come in the rest of the stream. And it's of course 1, 2, 3, 4, 5, 6 bytes. 22 is the unit ID. 4 is the function code, which is read input register. 018 is our start address. Remember how we get that address? It's 30,019 minus 30,001, which is the lower limit of read input register of the input registers range, and we want number of registers 1. So what we looked at in the previous section is actually the reality. All right. And then the response, again, transaction identifier 1, protocol identifier 0, 05 is the number of bytes expected back, and of course it's 1, 2, 3, 4, 5. And we have the function code, the unit ID and function code reflected. Then we have the number of data bytes coming back, which is 2, which is 1 and 2 here, and our value of 35 psi. Notice there is no CRC, okay, because the error checking and error handling is taking place in TCP/IP. The IP frame and TCP frame and Ethernet frame we are not seeing here because it's been stripped off by the time we reach this juncture. So we're not seeing all that, and you won't see all that, and you don't need to know about all that. Okay. So let's look again. Let's look now at the second time it queried it, because it's constantly polling it, right? Notice the transaction identifier has changed to 2, and the rest of it is the same. And the response for it, the transaction identifier is 2. If we go again, the third query, transaction identifier is 3, and the response is 3. So every time modscan32 generates a new query and it does what you call a new poll, it will increase the transaction identifier by 1. It'll increment it by 1 so that there are pairs of queries and responses. Okay, so this is what I spoke about earlier, and we need this, the protocol needs this transaction identifier because of the asynchronous nature of Ethernet networks. Things can come in, queries can go out without waiting on responses, and that is why we need that. So very, very important to recognize the transaction identifier and the fact that it increments. Okay. All right, so I want to give you an example of a read input register command simulated, and we're going to once again go back to our application design problem. In the previous section, we looked at a read input register 30,019 and a value of 35 psi at that location. So I'm going to disconnect temporarily, and I'm going to change this to 22. Well, that will be the PLC address. Unit ID. I'm going to change that to 19. Change this to 1. All right. And I'm going to change this. I'm going to update that to 35. Okay. So I'm going to do the same here. All right. And input register 30,019. Okay. So here we go again. Connect, IP address. And there we go. We have good communications taking place right here. All right, so this is an example of how you would set up ModScan32 and ModSim32 to perform this read input register communication. In the next lecture, what we're going to look at is the actual data streams associated with this particular conversation, because we had a look at those data streams in the previous section, and we want to make sure that they match really, really well, or exactly, of course, so that you will better be able to understand troubleshooting and recognize the data streams to do troubleshooting. Okay, good. All right, so before we go into setting up ModScan32 and ModSim32 to communicate with each other via Modbus TCP IP, we have to first get the IP address of this computer. And hopefully, well, actually not hopefully, you all will have to do that as well when you're using ModScan32 and ModSim32, because I really want you all to do what I'm doing here. All right, so I'm going to go to start, and I'm just going to type in CMD, which is the command prompt. All right, and I'm going to type this very simple command, ipconfig, and I have a lot of network interfaces here, but you're going to be looking for something like IPv4 address or IPv6, and my address here, 192.168.1.101, is the IP address of this computer. And that's the IP address given out by the Wi-Fi router that I'm connected to. All right, so we're going to be using this IP address when we're setting up ModScan32 and ModSim32 to talk Modbus TCP IP. All right. All right, so I have open here on my laptop ModSim32 and ModScan32. And if you did Mastering Modbus RS-485 Network Communication, you would be very familiar with these two. In that course, we connected our ModScan master to our ModSim32 slave via an application called Virtual Serial Port, which created two serial ports interconnected in software. In this example now that I'm going to show you, we're actually going to connect these two via the network using Modbus TCP IP. ModScan32 will be our client, ModSim32 will be our server. Now, usually on a network, each device would have its own IP address. A client would have its own IP address, and the server would have its own IP address. However, ModScan and ModSim32 can have the same IP address because it's the same IP address on this PC, and actually talk to the same port, 502. So as simulators, they're able to do that. So we're going to take advantage of that. So let's see what we do to connect. So I'm going to connect, and you'll see Modbus/TCP server. I'm going to connect there, and if I go disconnect, I see that there it's already connected. So we're successfully connected as a Modbus server. All right, and what I'm going to do is I'm going to start new holding register. Let's say device ID is 1, address is 1, and length is 1. I'm going to put input register 30,001. All right. And I'm going to go now to my ModScan32, which will be my client, and it has to connect to the server. And usually I'll connect to a port, but in this drop-down, you'll see remote TCP IP server. And I know ModSim32 is not exactly remote, but from a software perspective, it is. So this is the IP address of the remote Modbus server, which is ModSim32. It's 192.168.1.101, which from the previous video I showed you was the IP address of my laptop. And we're going to go OK. And we're connected. I can go disconnect if I want. And now I can go new. And I can see 1 and 1 and 1 and input register. Gonna just move this around a bit. So now I'm connected. So I am actually, what's happening here is that ModScan32 is communicating with ModSim32 via Modbus TCP IP. And of course, we're going to see lots of examples of it. If I double click this here and change the value to 345 and update it, it updates immediately on ModScan32 because there is a connection between both of them. And in the lectures to come, we're going to go through one by one all of the various Modbus commands, because I want to show you that they work on Modbus TCP IP, and I want to show you what the data streams look like, because you'll need that to troubleshoot. Okay, so when you first start the ModScan 32 application, this is what you will probably get. You might get some messages as you have the trial version that says, you have a certain amount of time left, etc., etc. I have the full version, so I'm not getting those messages. So ModScan 32 is a Modbus master simulator. And if you recall, Modbus masters, one of the things that they do a lot of is acquire data from Modbus slaves, right? To do so, they have to have an idea of the unit ID of the slave plus the register address or register addresses. Remember that. So how do we tell ModScan to act like a master in a certain way? Well, let me use an example. Remember our very first example where we were looking at the query response cycle, where we were acquiring the pressure at 30,019 from PLC with ID 22? Device ID here is the unit ID of the slave we want to connect to. And I'm going to, from the example, I'm just going to put 22. All right. So when we're using ModScan 32, we put the ID, unit ID of the slave we want to contact. And that would tell ModScan 32 to send out data to try to contact unit ID 22 slave. Address. This is our start address that identifies the start of the address block we want to read, right? Or blocks. I'm going to put 19 there. And since there's only one register we're going to read, I'll put 1 there. And it's an input register we want to read. Now notice this drop down, it has 0, 1, 2, 3, 4. Notice those are the function codes that represent the different function code names. So we want to read an input register. So note how I've just set this up. This is a Modbus master. I'm telling it, you know what? Read from a PLC with unit ID 22, start at address 19, and length 1 register, and it's an input register. Now notice I don't put 30,019 because when I select input register, it adds the 30,000 onto it. That's how this particular Modbus simulator works, right? So you see right down here now, it actually has the address 30,019 that we want to read. It also has device not connected. All right. We'll connect it soon enough. So some things to notice here. These we will be using. These are different mathematical representations of the data. And we'll also be flipping from show data to show traffic, back and forth like that, right? Okay. All right, so far we've had a look at the virtual serial port kit application and the ModScan 32 application. Now I'm going to look at the ModSim 32 application. And remember, this is a Modbus slave simulator, whereas the ModScan 32 is a Modbus master simulator. So remember what Modbus slaves do? They wait for messages from the master and then respond accordingly. So when you start ModSim 32, you may get similar messages about demo and all that sort of thing. I'm not getting it here because I have a full version, right? And it starts off blank like this, and you go to File and click New, and you get a new window. And I'm going to move this window, sort of expand it a bit. There we go. And you can see it's a similar setup to the ModScan 32, except we're actually not programming it to send messages, but programming it to actually have certain registers, and it'll send messages automatically based on queries from the slave. So let's follow our same example. Let's put 22 here. I'm creating a slave with unit ID 22, and I am creating address 19 and 1, and I'm going to select input register. So what I've done right there is I've set up a slave device, or PLC in this case, with device ID 22 and a register in there, an input register 30,019.